Start.
Hello everyone. This presentation is based on a case study focusing on improving the electric scooter and its companion mobile app. We have analyzed user feedback, explored new features, ideas, tackled new technical challenges, and proposed smart solutions using modern technologies like cloud integration and AI. Let's dive into some of the most important findings and recommendations. Uh, Let us discuss the questions. Next slide.
Okay, so first question is about a scenario of the company which wants to do an analysis of the app and what it needs to improve it. So there are top 10 features. First is real-time battery insights. So basically it will display battery percentage or the remaining range and smart low battery alerts. Second is Google Maps integration. With efficient battery routing and nearby charging stations, it will provide navigations about these two. Third is ride analytics dashboard. So, tracking the ride data like the distance, speed, and eco driving score to monitor the performance of that particular vehicle. Fourth is modern user-friendly UI UX. UI UX that will be easier for the user to understand, which would be clean and customizable interface with quick access like shortcuts and dark mode. Fifth is document storage and dashboard sync, uploading and viewing all the important documents like the insurance and PUC directly on the app or the tablet dashboard. Next 5 features are OTA, also stands for over the air updates. So it will automatically update the app and scooter firmware with new features and also the bug fixes. Next is remote unlock, lock and anti-theft. So the scooter will remotely be locked and unlocked, and the user will also get theft alerts with real-time tracking. Next is multi-user support. The user's friends or families can also access this app with role-based permissions and also track the usage logs. Next is live charging station finders. It will help locate nearby charging stations with optimal charging recommendations and also live availability. Next is vehicle health monitoring. So we will get real-time diagnostics, maintenance alerts and also service reminders with the help of this feature. Next. So let's see the most useful features and why they are useful. First is real-time battery status and smart alerts. So basically there were complaints about sudden charge drops through the customers. So this feature will basically predict range alerts and alert the user accordingly if the battery is low. It will also charge drain analytics and it will help user to enhance trust and prevent breakdowns. Next is Google Maps integration with charging points. To make the navigation smoother and enabling battery aware trip planning, it can be a big help for long distance traveling or maybe the first time users. So it will greatly improve utility and align with competitor advantages. Third is ride history and vehicle health monitoring. So it will track daily rides, speed, and it will detect issues beforehand via sensors or BMS, and it will proactive maintenance lower breakdown risk. So it will improve longevity of vehicle and also enhance user confidence. Next. Fourth is over the air updates and real-time notifications. So there are complaints about outdated data and buggy notifications. So this will allow live patching, firmware updates and UI enhancement. This will keep the app updated without actually visiting the service centers offline. Fifth is document upload and dashboard sync. So new feature that will offer legal and convenience value. It will store important documents like license, insurance and RC directly in the app, and it will also display them on the scooter's dashboard. So it will reduce the need to carry hardware paper documents and also increase digital convenience. Next. So the next question is, what are some of the design considerations you would have for designing the storage feature, and what all will you need to consider for security of the documents while designing the architecture? So firstly, design considerations for document storage. First is user experience, that is UX. The user experience should be simple, intuitive, and there should be intuitive upload process with drag and drop option. Second is support for multiple file formats like the PDF, JPG or the docs, and there should be a preview option before finally uploading the document. Automatic documentation categorization for easy organization. Next is cloud storage. We should use scalable cloud storage, example AWS, Google Cloud, to handle the growing data, and apply compression for storage efficiency. Backup and sync documents across all devices automatically. Next. Third is user interface. The user interface should be smooth, and the integration within the app and vehicle dashboard should also be smooth. There should be progress indicators for large file uploads. Last is document organization and search. We may implement search and filter options to sort document by their type or date, and provide alerts for time sensitive documents, example as expiration of an insurance. Security considerations for document storage. First is encryption. Encrypt data in the transit using HTTPS and at rest using AES 256. Second is authentication and authorization. It may require multiple factor authentication, MFA, for secure access. Implement role-based access control, RBCA, for document permissions. Secure session management with automatic logout after inactivity. Next. Third is data integrity and validation. For file integrity and validation of file types, we will use checksums and hashing. Backup and recovery. Ensure redundant backups and a disaster recovery plan for document retrievals. Fifth is audit and monitoring. Keep activity logs for tracking document access and changes if any. Monitor for suspicious activity to detect potential threats for security. Last is legal compliance. Will ensure compliance with GDPR and data retention policies, offering document deletion requests.
Let us begin with the third question, which is identifying reasons behind customer complaints and how to test and fix them. So complaint one is user reported discomfort while riding on gravel or non-tarred roads. Uh, Two key reasons stood out, which are first is the suspension system may not be equipped to handle a rough terrain, and second one is tire design might not provide enough traction or flexibility. To address this, we designed two test scenarios. Uh, to address this, we have designed two test scenarios. One is a suspension test on gravel at various speeds to check if the ride remains smooth and controlled. And second one is a tire performance test on non-tarred roads, where we expect the tires to provide strong grip and stability. Complaint 2, next slide, which is charging is taking longer and frequent use, and the battery often die without warning. This could be due to battery degradation over time and charging circuit issues causing inaccurate readings. We planned these tests. First is a changing time test to ensure a full charge stays within expected time limits. And second is a battery level accuracy test, which is to provide if the app gives correct charge percentage and low battery alerts. These tests aim to fix comfort and reliability issue, uh, the two pillars of user satisfaction. Next question. Next. Fourth question. Now the fourth question. How do we launch the new version of the app using a structured approach? We used inside out and outside in technology for planning. Inside out planning focuses on internal readiness. Here are the top 5 steps. First is finalizing all app features and conduct through QA testing. Second is run internal beta testing and employees to identify bugs early. Then third one is set up a scalable cloud infrastructure for live user traffic. Then fourth one is train customer support teams and prepare help documentation. And fifth one is prepare app store assets, including screenshots, description, and compliance checking. Next slide. Outside in planning is about market perspective. Here are our top 5 actions. First one is conduct user research and analyze competitors to build valuable features. Second one is segment the audience. For example, first time versus returning users, and personalize the experience. Third one is focused launch and marketing strategy across digital channels. Fourth one is design smooth user onboarding while tool tips, walkthroughs, and in-app helps. And fifth one is monitoring real-time analytics after launch and iterate based on behavior. Uh, this dual approach helps us deliver a product that is not only technically robust but also market ready. Uh, then next slide, we move toward conclusion. No, sorry. Fifth question.
Myself, Jyoti Hubale. Now, from the fifth question, I will continue. So, the fifth question is based on the list of top 10 features you have selected, do a relative priority exercise to mark them from P1 and P2 and then from 1 to 10 and explain what you have decided those priorities. So, we picked the top 10 features from for the new electric scooter app and ranked them based on priorities. P1 is the must have, very important priority, and P2 is nice to have. It's a less urgent priority. And ranks are given from 1 to 10. This is a priority classification feature. Real-time battery status and alerts. This is the most important priority, and it has given a first rank because this helps the rider know how much battery is left and prevents sudden breakdowns. It's the most important because users complain about unaccepted battery draining. Second feature is navigation with Google Maps. It is a second rank. Riders need a map to plan their trips easily. It's essential in cities and improves the ride experience. Third feature is smart charging recommendation. This has given a third rank because The app can tell when and how to charge the battery better, helping it last longer and stay healthy. Fourth feature is trip history and ride analytics. It has a fourth priority rank because riders can see where they have been and how they drive. It makes the app more useful and engaging. Fifth feature is vehicle diagnostics. This is have given a fifth rank because it shows the health of the vehicle and warns if something wrong. Help fix problems early. Sixth feature is service booking and alerts. Um, it has given a sixth rank because good for reminding users about servicing the vehicle, but not needed all the time. Next feature is OTA, over the air updates. This has given the seventh rank because this allows the app and vehicle to get updates without going to a service center. Useful but happens occasionally. Eighth feature, document upload and storage. This is the eighth rank feature because lets user keep vehicle related documents in the app. It's convenient but not critical. Ninth feature is rider behavior analysis. The reason for this feature is that the app can study how the rider drives and give feedback later. It's future focused, not urgent now. And the 10th rank feature is theft detection and geofencing. This is a very less priority feature because it adds security by alerting if the scooter moves out of a set area, but it's not used daily, so it's lower priority. Next, sixth question is the company is collecting the data in the cloud already but have had performance issues to update, collect the data and update the app. What can be the reasons for that and what would need to be improved for the data? Integration from the vehicle to the cloud and to send the data post analysis to the app. So the causes of performance issues are inefficient APIs. The system that transfers data between app and cloud is very slow or outdated. Then the cloud database is not organized properly, causing slow searches or updates. That's why poor data structuring is also one of the cause. Then lack of edge processing means all raw data is sent to the cloud without any filtering, which takes up time and bandwidth. Then the scooter may have a weak or unstable internet connection while sending the data. That's why low network bandwidth it is also a cause. Bad caching or synchronization means data is not stored or updated smartly between the scooter, cloud, and app. Now let's see how these causes can be improvement. Implement edge computing cloud upload. So this is a process some data on the scooter itself before sending it to the cloud. It becomes faster and more efficient. Next, efficient data formula. It is in compact data formats like protocol buffers instead of heavy ones like JSON to reduce size and speed up transfer. Next, API optimization. Use batching compression and rate limiting so API don't overload. Then scalable cloud services and performance monitoring also can be the improvements. Next question is The company would like the app to have intelligence and provide recommendations to the driver. What kind of data should the app collect from the vehicle, and what kind of recommendations can be done? Is there a possibility to use machine learning and or artificial intelligence for this analysis, and if so, what can be the use cases? So we want the app to be smart like a digital assistant for the rider. To do this, we will use machine learning and artificial intelligence to provide smart suggestions and alerts. So for data to be collected is battery information, temperature, voltage, charge, cycles, then location and routes, GPS data and travel patterns, driving behavior like speed, acceleration, braking, charging habits, where and when user charge their scooter. Then recommendations to riders. Here are some smart suggestions the app can give. Charge at home tonight to avoid low battery tomorrow. Based on trip data, try smoother braking to protect battery life. Based on riding style, switch to eco mode now to reach your destination safety. Then these are the some machine learning and AI based be used, and AI can make the app more powerful through these features. These are the use cases like predictive maintenance. This predicts parts failure before it happens using past data. Then smart routing suggests the best route based on traffic and battery. Energy optimization tells users when to charge for best battery health. Then personalized tips gives custom advice based on how the rider drives, and anomaly detection detects anything unusual like sudden battery drain or theft. Eighth question: use the product solutioning concepts and create a mind the new version of the vehicle, explaining the goals, features, changes, and UI changes, if any, you want to target in the scope. Let's plan the entire new version of the scooter using a mind map approach. This helps organize everything: goals, features, and design. Goals. What we want to achieve uh, are better customer satisfaction, then become second best in the market. Currently, we are on the fourth. Turn losses into profits from 10% loss to 10% gain, and have zero major complaints after launch. Core features. Key features we will add to the new version are a tablet dashboard with the touchscreen, Google Map integration, faster charging under 4 hours, app that connects to cloud and gives smart suggestions, lightweight design for better handling and efficiency. Then we will improve how the app and dashboard feel and function. It includes clean and simple interface, consistent and helpful notifications, clear battery range display, and navigation visible both on the app and the dashboard. Design changes that make the interface easier and more modern are dark and light mode options for readability, home screen widgets showing battery weather, trip stats, swipe and gesture for easy use on the tablet, for quick access to features, charging documents, and settings.
Uh, to con- to conclude, the new version of an electric scooter is not just a product upgrade; it's a strategic leap forward. We have tackled real user concerns like suspension comfort, battery accuracy, and app usability. We are adding intelligent features like predictive maintenance, smart navigation, and real-time diagnostics. With a clear rollout strategy and a feature-focused mindset, we aim to move forward from customer satisfaction to customer delight. Thank you very much. Thank you.